Good afternoon, ladies and gentlemen. Welcome to Math 30-2, Chapter 8.2, Properties of a Sine Graph. Now, with a sine graph, remember, we've talked about the grade 10, grade 11, we talked about this. The sine graph goes like this. So we talked about the period, how often it repeats. We talked about the amplitude, how high it is from the midline, or the middle of the graph. So, that's the big things we're going to be talking about today, period, amplitude, and midline. Now, put that in more formal terms, our objective to describe orally and in written form the characteristics of a sinusoidal function by analyzing its graph. Sinusoidal is a fancy name for sine. So on your calculator, that's the sine button. Now, I'm going to play a Khan Academy video that I think really nicely explains all this. All right? So you guys watch him for a few minutes, and I'll come back.
We have a periodic function depicted here. What I want you to do is think about what the midline of this function is. The midline is a line, a horizontal line, where half of the function is above it and half of the function is below it. Then I want you to think about the amplitude. How far does this function vary from that midline? Either how far above does it go or how far does it go below? And it should be the same amount because the midline should be between the highest and the lowest points. And then finally think about what the period of this function is. How long do you have to, how much do you have to have a change in x to get to the same point in the cycle of this periodic function? So I encourage you to pause the video now and think about those questions. So let's tackle.
So stop and think about it. Where's the midline? What's the amplitude and what's the period? When does it repeat?
The midline first. So one way to think about it is, well, how high does this function go? Well, the highest y value for this function we see is 4. It keeps hitting 4 on a fairly regular basis, and we'll talk about how regular that is when we talk about the period. And what's the lowest value that this function gets to? Well, it gets to y equals negative 2. So what's halfway between 4 and negative 2? Well, you could eyeball it, or you could count, or you could literally just take the average between 4 and negative 2. So the midline is going to be the horizontal line. Y is equal to 4 plus negative 2 over 2. Just literally the mean, the arithmetic mean between 4 and negative 2, the average of 4 and negative 2, which is just going to be equal to 1. So the line y equals 1 is the midline. So that's the midline right over here. Can you see that? You see that it's kind of cutting the function in. It's where you have half of the function is above it and half of the function is below it. So that's the midline. Midline. Now let's think about the amplitude. Well, the amplitude is how much this function varies from the midline, either above the midline or below the midline. And the midline's in the middle, so it's going to be the same amount whether you go above or below. So one way to say it is, well, at this maximum point right over here, how far above the midline is this? How far above the midline is this? Well, to get from 1 to 4, you have to go, you're 3 above the midline. Another way of thinking about it, this maximum point is y equals 4 minus y equals 1. Well, your y can go as much as 3 above the midline. Or you could say your y value could be as much as 3 below the midline. That's this point right over here. 1 minus 3 is negative 1. So your amplitude right over here is equal to 3. You can vary as much as 3 either above the midline or below the midline. Finally, the period. And when I think about the period, I try to look for a relatively convenient spot on the curve. I'm calling this a convenient spot because it's at a nice, when x is at negative 2, y is at 1, it's at a nice integer value. And so what I want to do is keep traveling along this curve until I get to the same y value, but not just the same value, y value, but the y value, I get the same y value and I'm also traveling in the same direction. So for example, let's travel along this curve. So essentially, our x is increasing, our x keeps increasing. Now you might say, hey, have I completed a cycle here? Because once again, y is equal to 1. You haven't completed a cycle here because notice over here, where our y is increasing as x increases, while here our y is decreasing as x increases. Our slope is positive here, our slope is negative here. So this isn't the same point on the cycle. We need to get to the point where y once again equals 1, or we could say, especially in this case, we're at the midline again, but our slope is increasing. So let's just keep going. Let's just keep going. So that gets us to right over there. So notice, now we've completed one cycle. So the change in x needed to complete one cycle, that is your period. So to go from -2 to 0, your period is 2. So your period here is 2. And you can do it again. So we're at that point. Let's see, we want to get back to a point where we're at the midline. And if I just happen to start right over here at the midline. I can start really at any point. You want to get to the same point, but also where the slope is the same. We're at the same point in the cycle once again. So I could go, so if I travel 1, I'm at the midline again, but I'm now going down. So I have to go further. Now I am back at that same point in the cycle. I'm at y equals 1 and the slope is positive. And notice, I traveled, my change in x was the length of the period. It was 2.
Okay, ladies and gentlemen. Now, as I said, I like that video because he nicely explains all this stuff. And it's interesting not hearing my voice. Oh, can't see that. Sorry, and it's interesting you don't have to listen to my voice. Not that my voice is not deep and mellow and soothing like his. Anyway, so period, amplitude, midline. That's what he's talking about. So there is the link if you want to look it up, or just Google it, YouTube, Khan Academy, midline, amplitude, period. Now, definitions you got to know. Period, the horizontal distance between consecutive maximum points. Now that's one nice definition. Now amplitude is the positive vertical distance between, amplitude is a positive vertical distance between the midline and the maximum. And finally, midline is the maximum and minimum divided by 2. Now, there's 3 definitions that are pretty good. There are others. The gentleman from Khan Academy used a different definition for period. I don't care. As long as you can come up with some sort of definition and explain it to me and understand it. Now, as I say where I come from, blah, 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 blah. Here's a sine graph. Now, big question, what's the period? Now, on the Khan Academy video, he started here, and he did one complete wave, or one complete cycle. Going up here, going up here. Perfectly good. Absolutely no problems with it. Now, here it's a little hard to see on this, but on your paper, this is minus 360 degrees, and this is 0. So the period, that is, how often does it repeat? Every 360 degrees. All right? Now, I want to point out something here. That's one way to measure it. Now, the problem is sometimes the midline is hard to find. But you're going minus 1 is the bottom, plus 1 is the top, so 0 is the midline. All right? Now, that's easy to find. Sometimes it's a pain in the bum. So I cheat. I go, where's the top? And where's the next top? Or next peak? Minus 270 to 90, that's 300 degrees. 360, sorry. Now, so far so good? All right, so as I said, top to top is easiest. Sometimes in the graphs, this is just the way it is. Bottom to the next bottom will give you the same number. Just sometimes it's easier to measure, or the numbers are nicer. Minus 90 to 270 is 360 degrees. Okay? And the amplitude, distance from the middle to the top is 1. Okay? Now I did that kind of quickly. I'll do the next one a little slower. Okay? Now, some tricks. When you're going to graph this, and that is, I'm going to give you the equation, you put it on your graphing calculator, check what mode you're in. So, grab your graphing calculator. Mode button up by the blue. make certain you're in degree mode. This one is in radians. The TI series will automatically go to radian by default. You don't want that. Put it in degrees. All right? Change mode to degrees. Then your windows. I'm going to say this once nicely. 0 to 360 for x. I'm going to say slightly sarcastically. 0 to 360. Don't make me say it unhappily. Okay? Now, your y values. From here on in, I want y is minimum minus 2, maximum plus 2. Now I'm going to say that once nicely. Y minimum minus 2, y maximum plus 2. Now I'm going to say it sarcastically. Y minimum minus 2, maximum plus 2. Don't make me say it a third time. Okay, now, graph it. So just grab your graphing calculator. And graph this. Sine x. It should be like that. Now you notice the x-axis has a whole bunch of lines because I forgot to change my scale. I'll put a line every 30 degrees. That'll make it easier. And there you go. See the nice sine graph? Up and down, up and down. So, what can you say about the amplitude there? How high does it go? Well, that's kind of a bad question. The better question is, where's the midline? Well, the midline is right where y equals 0. Right down the middle. Now, what's the amplitude? 1. What's the period? How often does it repeat? Every 360 degrees. The minimum, now, minimum x value or minimum y value. This was badly worded. Now, minimum x value is 0. Maximum 360 degrees. Now, however, I could mean minimum and maximum y values. So y value, the maximum value, the minimum is minus 1. Look at your graph. As low as it goes is minus 1. Or look at your table of values. And the biggest y value is plus 1. Now, here, domain. What have you graphed? You graph the sine graph from 0 to 360 degrees. Red. Okay. And what's the range? Well, it goes from minus 1 to 1. That's why I asked for the maximum, minimum, and maximum values. Okay? So far, so good? Good. Now, just look at your graph and double check it. Now, look at your table of values. Second table. And this goes 0, 1, 2, 3, 4, 5. You will die of old age before you get to 360. But I want you to scroll up for a sec. 0, minus 1, minus 2. You're getting numbers. This graph actually continues in both directions. You only drew 0 to 360. But someone always argues with me, but Mr. Sutton, the table of values keeps on going. I said draw from 0 to 360, so as far as you know, the graph goes from 0 to 360. However, if you think about it, that's not quite right. I could say domain x is all real, because you can plug in any value of x you want, check your data table, and you'll get a sine graph. So if I give you the picture, 0 to 360, it's only 0 to 360. If you want to argue with me about it goes on forever, you can argue with me. I'm just not going to because I'm old. Okay? Now, next one. Oh, sorry, summary. Now, what do we know about sine graphs? Well, as I said, here it goes, like that. It has multiple x-intercepts. It keeps hitting the x-axis. has one y-intercept. It crosses the y-axis once. Yes, it does have a domain of x is all real if you look at your table of values. Now, it has a range from -1 to 1. It has it has a range and an amplitude of 1. It goes up and down 1. And there's a period of 360 degrees. So one y-intercept has a domain of x is all real. So yes, you can argue with me, depending on the graph, what it looks like, but a sine graph usually its domain is all real. All right? So this is what you have to know, and this is the big part of this section, of this unit, chapter, this section, sorry. Multiple x-intercepts, one y-intercept, domain x is all real, range between -1 and 1, amplitude of 1 has a period of 360 degrees. Remember this. Stop staring at me like that. Okay. Come on. All right. Now, let's start screwing around with these and playing with Mr. Graphing Calculator. So, grab your graphing calculator and graph sine of 3x. Come on. All right. We'll work together. Graphing sine of 3x. Y equals 3 sine x, close bracket, graph. What do you get? Now, please tell me you're getting something like that. Now, what's the matter with that? Not a darn thing, except, look closely. Yes, you can't see the top and bottom. Now notice, multiplying it by 3. Could that mean, oh, maybe your amplitude is 3 times as high, or your graph is 3 times as high? So change your windows to say -4 to 4. When you do that, what do you see? The graph goes up to 3 and down to -3. Woohoo! What does the 3 change? Amplitude. And range are both 3 times bigger. -3 is less than or equal to y is less than or equal to 3. Has an amplitude of 3. All right? Now, so far so good? Remember, if I'm going too fast, pause the recording. All right? Got it? Now, clear that. And I want you to graph sine of x minus 5. Close bracket, minus 5 bracket. Sine of x minus 5 and graph, what do you get? Oh, come on. Where is it? What's going on? Where is it? Well, look at your table of values. It exists. Look when x is 0, what do you get? When x is 0, what do you get? Minus 5. So you're moving down 5. So your windows go down. Now I did the window minus 6 to 0 for y. And what have you got? A graph that moves down. This whole thing has moved down 5. Now that is my window for y is 0, minus 6 is less than or equal to y is less than or equal to 0, and I get to see the graph. And I'm going, ooh, what's happened? The midline is now minus 5, but everything else, oh, and the domain, the range. It's gone down 5. That's sneaky. And once again, everything's on the graphing calculator, but you have to play with your windows. So look at that. This one, the minus 5 means everything moves down 5. Okay? So, this leads to our sine function right on the formula sheet. You don't even have to memorize this. Y equals a sine square bracket b bracket x minus c close bracket plus d. What you do have to know is what each of these mean. A is the amplitude. D is the median or midline. The fancy name is median or average. The maximum is D plus A, and the minimum is D minus A. Okay? Now, let's go here. For the following graphs, identify the amplitude, the median, y equals a sine x plus d. Today, we're just dealing with a and d, and the max and minimum. Now, sorry, stop there for a sec. Amplitude and median. All right, so let's look at this graph. So, here's the graph, right here. So, what's the maximum value? Is 2, and the minimum value is minus 2. So, the amplitude, sorry, the median, the midline, D value. Where's the middle? 2 minus 2 is 0. So the middle is right here, or y equals 0. It's a better way to do it. The amplitude from the middle to the top is 2. The middle to the bottom is 2, so the amplitude is 2. That's A. That's D. So what is y equals a sine x plus d equation? This is y equals 2 sine of x plus 0. Now, you can grab your graphing calculator and graph this. 2 sine of x. Oh, this is in radians, so let's skip that for the moment. Now, we'll do the graphing later. Graphing in radians is a different class. So the maximum and minimum. So what's the maximum? And what's the minimum? Well, the maximum up here is y is plus 2. And the minimum down here is y is minus 2. So the max and minimum is that. Okay. Now, I'm going to stop there for a sec. Let me see max and minimum equation. That's right. Now, most of these you can eyeball, but I'm going to show you a couple of equations to go with them. So, here, what is the amplitude? Well, it's probably easier to figure out where the middle is. So you go up, down, up again. Your high point is 5, and the bottom is minus 1. So eyeballing it, what's halfway between 5 and minus 1? That's 2. Okay? Now, median. Why did I call it median? The middle. Forgive me. All right. Now, the amplitude. Amplitude. Let me show you the cheating shortcut for this. A equals max plus min over 2. No, sorry, max minus min, sorry. So the maximum value is 5. The minimum value is minus 1 over 2. Now, 5 minus minus 1, minus minus 1 is 5 plus 1. 5 plus 1 is 6. 6 divided by 2 is 3. So the amplitude is 3. Now you could have just eyeballed that. But anyway, well, I should show you the equation because some people like that. Max minus min. Now, the median, there actually is an equation for that. It's D is max plus min over 2. So the maximum is 5 plus minus 1 over 2. What's 5 plus? Well, it's 5 plus minus 1 or 5 minus 1. 4. What's 4 divided by 2? 2. So that's my D value. E equals 2. Should have shown, yeah, I'm showing you this. So, well, that is the maximum min equation I just did here. So y equals a sine x plus d. Y is 3 sine of x plus 2. Okay? So the maximum, I should do the maximum minimum equations first anyway. So I'm going to be quiet. You guys tell me the amplitude, the median. I should just call this D. A and D. And write it out as the equation. Okay? So pause the recording and do it. I said pause. Why are you still staring at me? Okay, welcome back. Amplitude. So it goes from down here, up here. So, amplitude is max minus min over 2. 9 minus 1 over 2. 9 plus 1 over 2. 10 over 2, which is 5. The median equation, or D, was max plus min over 2, which is 9 plus minus 1 over 2. 9 minus 1 over 2, 8 over 2, which is 4. Now, eyeballing it, did we get it right? D is 4, so 1, 2, 3, 4. That does look like the middle. And going up, 1, 2, 3, 4, 5. Going down, 5, yes. So this is y equals 5 sine of x plus 4. Okay? Now, is there one more or two more to do? I forget. I mean, where's that at? Yeah, there's a couple more. All right, so let's do them. Next one. Pause the recording. Give me the amplitude and the D and median. Welcome back. Amplitude A equals max minus min over 2. The heck's the maximum here? Maximum looks like 10. The minimum is minus 10. Minus minus 10. Minusing a negative is adding. 10 plus 10 over 2. 20 over 2, which is 10. So A equals 10. What is the median, or the middle? D equals max plus min over 2, which is 10 plus negative 10. Or 10 plus negative 10, that's 10 minus 10. 10 minus 10 is 0. So this is y equals 10 sine of x. And if you really want to put in the plus 0 at the end, you can, but why? All right? Now, a couple more. Amplitude and median. Pause the recording. Do it and come back and check with me. Welcome back. Now, amplitude. Okay. A equals max minus min over 2. The maximum is minus 0.5. The minimum minus 1.5. 2. Okay. Now I need, oh, no. Minus 0.5. Minus and minus means a plus. So plus 1.5 over 2. What's minus 0.5 plus 1.5? 1 over 2. A is 1/2 or 0.5, however you want to write it. D, the midline, or the median, is max plus min over 2, which is the maximum is minus 0.5 plus minus 0.5 minus 1.5 over 2. You owe somebody 50 cents and you owe somebody $1.50, you owe them minus 2. So D is minus 1. So this is y equals 0.5 sine of x minus 1. All right? I'm going to let you look at that for a moment. All right. So that's how that goes. Yes, I did that kind of quickly, but by now you should know how to do it. If you're still having trouble, no, you don't rewind. Go back and watch it again. All right? Now, just to be a poohead, I want to show you a sneaky question. So on the diploma, you'd see something like this. What's the range of the following graph? What's range? Your y values. Now, here, look at the graph. Look a little closer. It goes up and it goes down. It's a sine graph, which means it has a maximum, it has a minimum, so it's not every y number. Now, looking at the graph, what's the smallest y value? It looks to be about 1. And what's the biggest y value? It looks to be between 4 and 6, which is about 5, or A. Minus 2 to 2, I have no idea where that came from, and 0 to 4, don't quite get that one. Anyway, so you could get a question like that, and you will in the homework. So that's it. Give the classwork 8.2 a try. When you get it done, look at the video for the answers. All right? Have a good one.